So to understand peroxides, a good place to start is the peroxide ion. So it's O2, 2 negative. So a way to visualize this is to understand that instead of what you expect, O has formed a single bond between the two oxygen atoms. You can see now I have kind of drawn the Lewis diagram. There's an electron there, an electron there being shared between our two oxygen atoms. These oxygen atoms aren't happy because in reality they still only have 7 total electrons. So this oxygen atom right here has got 1, 2, 3, 4, 5, 6, 7, and this oxygen atom's got 1, 2, 3, 4, 5, 6, 7 total electrons. So they still both want 1 electron. So what can happen is, let's imagine magnesium coming over. We know that magnesium's got 2 outer electrons. Magnesium can share these 2 electrons over to oxygen. So that's what's going to happen now. So magnesium shares these electrons and they go over. And what the formula you end up with is you end up with magnesium Mg, because there's only 1 atom of magnesium needed, O2, because you had 2 oxygen atoms, which is different, and so that would be magnesium peroxide, which is different from magnesium oxide, because in magnesium oxide you have the lone 1 oxygen with 1, 2, 3, 4, 5, 6 electrons. Magnesium shares its 2 valence electrons right here and here, and that's why you get a 1-to-1 ratio of magnesium to oxygen. So you have your 1 magnesium and your 1 oxygen. In this situation, you've got for every 1 magnesium, 2 oxygens, and that's what makes it a peroxide versus a just oxide. I'm not sure if that helps explain, but let's look at tin and look at a tin example since you seem to talk about that. So I'm just going to go to my next slide. Or not. There we go. So in this situation, we're going to look at tin. So let's use tin 2 peroxide. So I'll just write it down to start. Tin 2 peroxide. So here you know you have tin 2. So you know tin is Sn, and you know that it's 2 positive. So if it helps you to draw it out, the other way you can visualize this is you know that it's O2 bracket 2 negative. So crisscross it to get Sn 2 O2 2. And that can be reduced now because you have a ratio of 2 to 2. Oops, I didn't mean to do that. What you should reduce that down to is SnO2. And if that's kind of confusing, imagine back to our diagram. You've got the 2 oxygens, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and now you're trying to figure out, well, what's going to happen? Tin's going to lose 2 electrons. 1 electron's going to go here, 1 electron's going to go here. So you need 1 tin atom for every 2 oxygens in a peroxide. I hope that helps explain.